Let's parameterize the motion around a circle of radius 5, and let's suppose that it's going to take 12 time units to get around the circle one time. So we're going to have a period of 12. We're starting at the positive x-axis and going counterclockwise around the circle. So we're going to be able to use our regular cosine and sine. So we could say that any point at a given time t is going to be, now I need to make it, make the radius of the circle equal to 5. So I'll start off with 5 cosine t. Oops, not t. 5 times a cosine, and also 5 sine. But we don't just get to use cosine of t like I almost wrote. Since the period is equal to 12, the coefficient is going to be 2 pi divided by 12. So our coefficient of t is going to be pi over 6. This will stretch 2 pi out into 12. I'm going to multiply time by a constant pi over 6. This will turn 2 pi into 12. So my coefficient is going to be pi over 6 times t. So here are the points. Cosine x is in the x position, and sine in the y position is going to give us a circle that will start off at the positive x-axis and go around one time counterclockwise. Pi over 6 is going to make sure it makes one revolution in 12 units rather than 2 pi units, because pi over 6 times 12 will end up being 2 pi. We could think of this as in terms of a vector. So we can write r of t and make a vector valued function that would be 5 cosine pi over 6t I plus 5 sine pi over 6t times j. So evaluating this vector at any point would tell us label it differently. So there's the vector r of t as it goes around the circle. So here's the vector r. For different values of t, it'll start off pointing in the positive x direction, and then it'll just point around the circle counterclockwise. Any questions? So here's our position function. Let's make some calculations with this. Let's do some of our normal calculus stuff to this function. We've just started a new thing. We're looking at functions. And after we looked at functions in Calc 1, what did we do? That's right, derivatives. So let's take some derivatives. So if we look at r prime of t, this is going to be the velocity. And so the derivative of cosine is negative sine. So I have negative, derivative of cosine is negative sine. So negative something times the sine of pi over 6t times I. The derivative of sine is cosine. So I'll have plus something times the cosine of pi over 6t times j. So the derivative of cosine of pi over 6 times t is going to be negative sine of pi over 6 times t times pi over 6, multiplied by the derivative of the inside for the chain rule. So we'll have a coefficient of negative 5 pi over 6, and that'll happen in both coordinates. And this will be the velocity. So our velocity is just the derivative of each of the components. Here's what we want to look at. So at this point, notice that we have 5 cosine and 5 sine for a position. We want to think about what's the direction going to be for the velocity. So here we're going negative sine and negative cosine, and it's been stretched a little bit. So let's pick a point and find the position and the velocity. Actually, no, let's do one more derivative. So let's look at a second derivative. So the derivative of negative sine is going to be negative cosine of pi over 6 times t. And we'll have the derivative of cosine is going to be negative sine. We're going to have the coefficient 5 pi over 6 will carry along, but we'll have to multiply by the derivative of the inside. So it's going to be negative 5 pi squared over 36. And that will be both coefficients. I spelled 5 wrong. This will be our velocity derivative. And so that will be our acceleration. I realized only too late that I did not have space to write acceleration over here. So I had to kind of Mario World it and wrap it around to the other side, Pac-Man style. All right. So let's pick a value of t and evaluate this function. These 3 functions, the position, the velocity, and the acceleration. All right. I want to look at the point when t is equal to 6. Let's see what happens. So our position should end up being negative 5, 0. Let's make sure that this happens. So r of t, or r of 6, is going to be 5 cosine of pi over 6 times 6i plus 5 sine pi over 6 times 6j. As we suspected, we get the point negative 5, 0. Oops. So let's write it as a vector. So I'm starting to write things as vectors. So negative 5i plus 0j. Normally wouldn't write that, but we're trying to make a point. So that vector is at negative 5, 0. Let's look at the velocity at that point and see if it matches our intuition of this motion around the circle. So let's look at v of 6. So that's going to be negative 5 pi over 6 times the sine of pi over 6 times 6i plus 5 pi over 6 times the cosine of pi over 6 times 6j. So we have sine of pi, which is 0, and cosine of pi over 6, cosine of pi, which is negative 1. So we get 0i minus 5 pi over 6j. So let's take a look at that vector and how it relates to our position vector. Our position vector was at -5, 0. So our position vector put us at this point here. And our velocity vector is 0i, so no side to side, all up and down, and it's pointing that direction. So our velocity vector is pointing down. That's exactly what we expect as we go around this circle. The velocity should be tangent to the circle at the point. So that confirms our intuition. Notice that the velocity vector is tangent to the circle at the point. And this is just as we suspected. Everything fits so far. Also, our position vector and our velocity vector, if we find the dot product, we can see that they are perpendicular. Our dot v is equal to 0 because they are perpendicular. So our velocity is tangent to the circle. So let's evaluate the acceleration. And we're going to suspect that the acceleration should also be tangent to the velocity. So let's look at our acceleration at 6. So I have -5 pi squared over 36 times the cosine of pi over 6 times 6i minus 5 pi squared over 36 times the sine of pi over 6 times 6j. So cosine of pi is -1. So negative times negative cancels out. So I get 5 pi squared over 36 times I. And sine of pi is equal to 0. So we have plus 0j. So at t equals 6, we are at our position is at -5, 0. Our velocity is 0 and -5 pi over 6, so it's pointing directly down. And our acceleration, our acceleration is pointing in the positive x direction. So our acceleration is pointing back towards the origin, and that makes sense. That's what's this change in velocity is what's pulling our velocity in this direction, and what causes our position to keep following around the circle. So our acceleration is tangent to the velocity and points back towards the center of the circle. And that's what keeps this motion going around the circle. Any questions? Great. Let's pause the video here and think about this.